Hi everyone. We're going to talk about indefinite integrals. The indefinite integral is the word indefinite is the opposite word of the definite. Okay, so indefinite is something that you can leave as an undefined form, while the definite integral is where the answer is just definite. It's a fixed here. Okay, so for this case, the indefinite integrals, okay, the result should come as a form of the expression, right? And then the definite integrals, that they will be leaving as a kind of static or fixed number. So that's the big difference. Okay, so we'll go for it. Okay, indefinite integrals. If you differentiate capital Fx, and that is the result of the differentiate. So little fx is a result of the differentiate, which is the derivative. And then we call it capital Fx is the integral of little x. So what we can do over here, look at the example. If you differentiate x cubed, that will come out as 3x squared. Okay. Then, okay, so here that way, this way, so differentiate and integrate back. So see what I'm talking. If the d over dx moves to the right hand side over here, so, and then integrals. So if you differentiate x cubed, it will be 3x squared. And then if you integrate 3x squared, there will be x cubed. So that's what you can manipulate. Another example, if you differentiate x cubed plus 5, it will be 3x squared. So the constant is disappeared. Okay? Therefore, we can say, integrate 3x squared will be that. Look at this one. Okay? So integrate 3x squared will be x cubed plus 5. Does it make sense, guys? Now, what you have to notice in this case, so on the right hand side, they are same integrals, but having different results. These are the same, but the constants are different. So due to the fact that if you integrate, there must be some kind of integral constant. So as per here, so we do not know what that is. Okay, so sometimes 5, sometimes 0, sometimes any other number. So we do not know what that is. Okay, that's one of the reasons why we call it indefinite. Okay, so we just leave it plus c. So it's plus c, maybe some other fixed number, maybe 0, maybe 5, maybe 10, maybe negative 100, depending on the question or situation. Okay, so that's the formula. So that's the basic formula. So n divided by n plus 1. And then increase the power 1 and plus c. So that's the basic formula. Okay? So look at the example over here. Integrate of x squared. So integrate x squared. So 2 plus 1, 2 plus 1. That's basically the basic rule of the integration. And then please do not forget about to write plus c at the end. Okay, does it make sense? And next step is just to make it simplified. Okay, so that's all that is. So a key point of this indefinite integral is to have plus c at the end. Okay, guys? Okay, let's do the question. The first question, do plus 1 plus 1. Okay, so do plus 1 plus 1. So 5 plus 1, 5 plus 1, and plus c at the end. Easy peasy, isn't it? And then simplify. So that is basically it. Okay, so that's the first question. Okay, we jump on to the next one. 3. Okay, well in this case, you may have to consider, say, if you differentiate 3x, so that will be 3. Therefore, if you integrate 3, that will be 3x, and then plus c here. So that's what I like you to do. Okay. So therefore, if you integrate 3, okay, you can consider, say, 3 times 1, which is 3 times x0. Then we can do plus 1 plus 1. That's just follows the basic integration rule. Okay, so 0 plus 1, 0 plus 1, 3 is just a constant. We just leave it as it is, and plus c, and then we'll get the same result like this one. Does it make sense? Yeah, easy. So make sure you do not have to do this process all the time. If you have a question like integrate the constant number, you just attach x on the right hand side and plus c. That's basically it. Okay, that's what usually we've been doing. Okay, but that just follows the basic rule, so you can just recognize, it still works by following the rule. Next one, 6x power 2 to the 7, yeah, okay, so still the same process. Whatever the coefficient is there, 7 plus 1, 7 plus 1, easy. So 6 on 8, x to the power of 8 plus c, and don't forget to make it simplified, which is 3 on 4. Okay, so that's how you do. Not too hard. Next one, a bit more complicated, but I can give you a tip for you. What you may need to do is to make the question simpler. Okay, so I suggest you to take this coefficient completely outside of the integral. So it doesn't matter. And then you can just integrate only whatever in the inside of the integral sign. So then the coefficients are leaving as it is, and then plus 1, and plus c. Just as usual. Okay, so key part of this question is take the coefficient completely outside of the integral. So that's the point. And then you can just simplify, okay? Okay, so question 5 there. Same story, okay, same story. Okay. Sometimes a bit dangerous for you, but same story. So completely take out them completely. Okay, 6 on 5, just take out completely. Now, that is not ready to be integrated, okay? So we're gonna make it a negative index. Yeah, then we can do plus 1 from this point. So minus 4 plus 1, negative 4 plus 1. That's it, okay? So simplify. So what was happening? That's negative 3. We cancel them out, which is 2. And then minus 4. Okay, negative 4 plus 1 becomes negative 3. Okay, we don't want to leave as a negative index. Take it down. That's all you want. Okay, so again, question 4 and question 5 refer the use of the coefficient. Okay, so always a great idea to take them out. Okay, make the question simpler. So for you to continue to solve the question, there's a peace of mind. Next one, yeah, looks horrible. However, it's not horrible at all. You can just integrate one at a time. Okay, so what you can do, just plus 1. So 3 plus 1, 3 plus 1. 5 is just there. It's a constant coefficient. 4 is just there. Okay, 4 plus 1, 4 plus 1. Normal. 3 is the coefficient, so 1 on 3. 5 plus 1, 5 plus 1. That's all that is. Just simplify. So that's it. You probably do want to make a single fraction, but not always the case. You just leave it. It is actually integrated. Okay, that's completely fine, guys. Don't worry about it. For this one, okay, few people made a mistake in the past. What has happened? They integrate them separately, which is completely incorrect. You can't actually do it. Okay. In doing this one, I like you to separate them into small, 3 small pieces. So what I mean is like that. Okay. So that one fraction, and middle another fraction, the other one the last fraction. Okay. Then simplify them by canceling them out. Okay. What you can do, maybe 3. Okay. For here, there, cancel out, and then this is 2. So write them as simple as possible. Then plus 1. Okay, so then plus 1. What's plus 1? 3 plus 1, 3 plus 1. Okay, so that used to be 1. So 1 plus 1, and half. You just add x on on top of the existing coefficient and simplify. So okay, so that's what we are looking for. Does it make sense, everyone? So everything, okay, is regarding to the plus 1 formula, which is the basic integration formula. So that's the basic. I covered a little bit of this, bits and pieces of the way how you can do better. So for example, you can separate them out. I talked about to take the coefficient completely outside the integral. That makes you to solve the question a lot easier than before. Okay, so that's the indefinite integral.